Hello.
Hello. Hello.
So let me just see if my video is even working. It may not be. Does not look like it is. That's interesting. Oh, well, I won't worry about the video then.
Right, my video's working.
I'm going to try again here. Something has happened when I reset my laptop. I think IT changed the settings again, which is always lovely. And one of the reasons we're doing this 15 minutes earlier.
Exactly.
Heaven help us all with this IT stuff. Participants, we got 3 folks on, and my video is still not cooperating. That's lovely. Well, it's not that important, but Dave, did you want to try sharing your screen, and we'll just see if that's
certainly
working?
Yeah.
I'm just going to pause.
Good evening, everybody. Good evening, everybody, on this wonderful 5th of November, both the U.S. Election Day as well as Guy Fawkes here in the U.K., which is a very special celebration. People use fireworks and bonfires to celebrate the occasion. Anyway, we're here for the Northern Line Extension Program and to hear a presentation by both the Head of Engineering, David Smith, and Senior Systems Engineer, Dave Thompson, to talk about the project. David Smith is a civil engineer with 40 years of experience, over 40 years of experience in construction, and the last 20 of which has been as the delivery project engineer for Transport for London, culminating in the head of engineering for the recently commissioned Northern Line extension to Battersea. Dave Thompson is a graduate. Following graduation in electrical and electronic engineering, Dave Thompson joined ICL as a mainframe computer design engineer, eventually becoming responsible for all of ICL's large and medium mainframe computer development. During the 1980s, created and headed up ICL's computer integrated manufacturing program, subsequently obtaining a PhD in computer science based on this innovative program. For the past 20 years, he has been a senior systems engineering working on large complex projects in London Underground and Transport for London. So let's welcome those 2 gentlemen. And Dave or David, please go ahead and start your presentation.
Okay, so good afternoon from the UK. Here it's 36 minutes past 5 in the afternoon on what we refer to as Guy Fawkes Night, when, of course, we're celebrating the fact that somebody nearly managed to blow up our parliament. They didn't, and we still got one, and the jury's out as to whether or not that's a good or a bad thing, to be perfectly honest. But there we are. So, yeah, my name is David Smith, and I'm a civil engineer. I have been in the industry for over 40 years. And yes, the last 20 years have been spent working for Transport for London as a delivery project engineer. My co-author for this evening is Dr. David Thompson. And Dave and I worked together on the Northern Line extension, myself as head of engineering, and Dave keeping me honest and technically correct from a systems engineering perspective. So I think that'll do by way of introduction. So if we could move to the next slide, please, Dave. So I'm going to tell you about the Northern Line extension. This presentation is about the Northern Line extension, something that both Dave and I are very proud of because it was a very successful piece of work, and I'll tell you a little bit more about that in a few moments. The starting point for myself and to a large extent for Dave joining the project was 2015, and the project was in considerable distress at that point, and therefore it's relevant to explain that sort of context. And I'm going to talk a little bit about the road to recovery from that point. I'm going to speak about the nature of the contract that we worked under because of the importance to the way that the work was conducted and the difficulties our contractor was faced with in terms of delivering on a contract that they didn't really understand when they signed up to it. We're going to talk about key tools and principles that were applied from a systems engineering perspective and from a general engineering principles perspective. Safety and technical assurance in terms of what we do and how we are comfortable that we are delivering something that is safe and fit for use into operational use. We're going to talk about the program schedule and how that relates to systems engineering and how we made sure that that's embedded in our migration planning. We're going to talk about commissioning and handover of the works and what we did in terms of getting the message across so that we brought everybody on the journey with us and what success ultimately looked like and why we believe we were successful. Next slide, please, Dave. So the Northern Line extension is the first significant extension of the underground in a generation, the last having been the Jubilee Line extension in the 30 odd years ago. The works were delivered on time and on budget at £1.2 billion sterling. This despite the fact that the latter stages of the programme of works were delivered during COVID. Now, I say delivered on time and on budget. That's very significant. It's the only project that I am aware of or programme of works in living memory that we managed to deliver on time and on budget. And so we are particularly proud of that, as I think you can probably imagine. The works were comprised of 2 new underground stations, one at Nine Elms and one at Battersea. The Battersea works had an oversight development which was taking place substantially coincident with us constructing the underground station at that location. So, and that introduced some serious complications, which I'll speak about a little bit more shortly. At Nine Elms, there was also an oversight development planned, but the works were, the oversight development was a follow-on activity as opposed to being coincident. And so that made that slightly less complex from our perspective. There were 3.2 kilometres of new concrete-lined tunnels with new cross passages in spheroidal graphite iron. Just cast iron to the layperson, but spheroidal graphite iron is something that we tunnel engineers, of which I consider myself to be one, use these days. It's a little bit more flexible than conventional cast iron. We had a step plate junction connection into the existing Northern Line via the Kennington loop using a combination of sprayed concrete and spheroidal graphite iron. You can see on the right-hand side, there's a little diagram. I'm sorry, the diagram isn't as clear as it perhaps might be. But nonetheless, on the far right-hand side, you can see, hopefully, the connection into what we call the Kennington loop. We made modifications to an existing station, Kennington station, to suit and to accommodate the additional footfall, including new inter-platform cross passages. Remember, we are constructing these or putting these new pieces of construction. They are being built in an environment that to some extent was in the order of 150 years old. And so that presented certain challenges as well. We had 2 new, we had a ventilation and fire evacuation facility partially enabled by 2 new access shafts. These shafts are sort of 15 meters or so deep, sometimes a little more, sometimes a little less, but of that order, as were the tunnels. A new signalling system tied into the existing signalling system, much of which is a bit antiquated by modern signalling standards, and so that also presented certain challenges. New communications and signage within the Northern Line extension and also across the LU system so that the LU system was aware and properly signed the new additions that we were in the process of constructing. And at its heart, this was a complex, multidisciplinary group of projects encompassing all aspects of the LU delivery mode of transport. Next slide, please, Dave. So, new start just ahead seemed appropriate. I joined back in 2015. Dave had been involved at an early stage and stepped away, and came back at a similar sort of time, as far as I recall. And Dave and I worked quite closely together at various stages to get things back on track. Next slide, please, Dave. So, as I say, the Northern Line extension got off to a difficult start. It commenced under a delivery arm called Tube Lines. Tube Lines were fronted up by a company that some of you will be aware of called Bechtel. In the early 2000s, the Underground entered into a public-private partnership with contractors, and Tube Lines was responsible for the Jubilee, Northern and Piccadilly lines within the Underground system for the ongoing maintenance of them and for any new works that needed to be constructed. At a point around the time when I joined the project, the transition from Tube Lines back into London Underground took place. The truth is, it wasn't terribly well managed, and certain people felt a little cast adrift, and we had to deal with that sort of psyche that was going on at the time when I joined the project. So 2015 also saw major commercial pressures caused by the difficulties we were having with the Battersea oversight developer at the same site where we were constructing the Underground station. Our design was relatively well advanced. Theirs was lagging some way behind. And as a consequence, design paths that they had told us would be suitable proved not to be the case. And we ended up having to a fairly major redesign of the Underground station in order to accommodate new low paths. And this created some real difficulties with our design and build contractor, because at the time there was real uncertainty as to how this was going to be funded. So those commercial pressures led to quite a confrontational approach from both our side and from the contractor's side. And it made getting them to do things which they were contractually obligated to do quite problematic if they hadn't properly thought it through and were clear how they were going to do it. And it's very clear that at this early stage, they hadn't really thought through the process of system integration, which they were obligated to do under the contract. We had, at that time, as is the way with difficult projects, a series of project or program leaders who came and left in short order. And as I said earlier, the project felt disenfranchised and lacked direction, and morale was most definitely at a low point. Next slide, please, Dave. So the road to recovery, what did we do? Next slide, please. So as I said earlier, the team were demoralized, and they were demoralized because they were working hard and appeared to be achieving very little. At least nothing was being recorded. They were not party to the grand plan. Indeed, there wasn't much of a grand plan, if truth be told. And in any event, what plan there wasn't being communicated to the ground troops. And as I've already said, leaders arrived and left in short order without appearing to make any appreciable improvements. So the first thing I did was I identified and started to communicate what was being achieved so that people had a sense that they were actually achieving something. Because things were being achieved. People were working really hard, but in something of a vacuum, quite honestly. And so it was important to make them aware that they were achieving some important things. I shared the program with them, such as it was, and I promised to share future developments of that program. I provided personal assurance that I and the new project director, because we both arrived at a similar time, were there to stay. And I produced an organogram so that the team could see where they sat in the grand scheme of things and how what they were doing related to the work of others. Next slide, please, Dave. So once I'd identified what I believed to be the core problems and begun rebuilding the team, I looked to engineering first principles for the building blocks of recovery. A project or program begins as a set of intended outcomes or requirements. And these are developed into designs, and the works are constructed in accordance with the design. The end goal is the provision of a system or interrelated systems that achieve intended outcomes. So this was my thinking, coupled with or born out of discussions with Dave and others. And it was apparent that, if we were going to make this happen, we needed a robust systems engineering approach to help us achieve the intended outcomes on time and within budget. And so this is the basis that I and Dave used to develop my understanding of the Northern Line Extension program and what needed to be delivered. Next slide, please, Dave. So the contract. So on NLE, we used the new engineering contract, which is a form of contract based on a mutual respect and cooperation. Those of you that have worked in construction industry will have a wry grin on their faces around that, I'm sure. But nonetheless, they are the principles, and this is what we tried to do. And indeed, in due course, we're able to achieve it, although our starting point was a tough one. So contractually, NLE was comprised of a large civil engineering and infrastructure construction project that was required to interface with and integrate into the existing LU infrastructure, and also Battersea oversight development. In addition, there was a design and implementation of complex subsystems, including signaling, comms, and there were 16 of these subsystem projects in all, which were being delivered by London Underground. So we had a design and build contractor. They were called Ferrovial Laing O'Rourke. They were a joint venture between Ferrovial Agraman and Laing O'Rourke, as you might expect from that. And they were appointed by LU to deliver item 1. But key here is also that we, that is to say LU, were responsible for the delivery of item 2. But the other key point is that the design and build contractor were also responsible for overall systems integration of items 1 and 2. So whilst they were not responsible for the delivery of items described in part 2, they were responsible for bringing together those pieces of design with their own design and making it an integrated design, and assuring the points of connection between our design, that is to say the joint venture design and our designs. Next slide, please, Dave.
I'm sorry.
Oh, we jumped one there. Okay. So one of the things we did was we looked at the difficult relationship we had, and we looked at what the contractor was doing, and we tried to help them. So I've said here new and novel, but underpinned by sound principles. So whilst the D&B contractor was responsible for overall systems integration, they didn't really understood what they meant, and they weren't properly equipped to do it. And so we had to work with them and educate them and guide them, which we were able to do because we had good people within our own LU team. And a great deal of patience was required. I suggested to some people in an earlier conversation that Dave Thompson had some Henry Kissinger kind of attributes in the way that he managed to bring people to the table and get people working together. And I really believe that was key to many of the successes we subsequently enjoyed. So we needed an effective systems integration that involved close liaison between ourselves and the design and build contractor. And we established a set of meetings to help us work to the strengths of the parties involved and to bolster the weaknesses that surely existed. Our LU systems engineering team created a systems architecture for the project using a track framework. and from this generated an objects and interface register, which was shared with the design and build contractor. The design and build contractor then took ownership of the objects and interface register in Excel form, comprising 240 key interfaces. The objects and interface register became a key tool for collaboration and was extended to become an all-encompassing interface control document rather than the traditional one ICD per interface. The Excel version objects and interface register was enhanced with tools to support the management and closeout of interface issues. This resulted in the most critical issues being highlighted for the weekly interface reviews between the LU and DB contractor, and continuous progress towards closeout of all issues was maintained. Next slide, please, Dave. So this is an indication of the ICD register that we put together. You can see down the left-hand side the various interfaces, and you can see all of the interface points and the disciplines involved in those interfaces. Next slide, please, Dave. Here you can see how we prioritize things using a color coding system. And the next slide, please, Dave. And here you can see how we populated the register with information about the interface and how and what evidence was gathered to show that the interface had been appropriately dealt with. Next slide, please, Dave. So some fundamentals. On the right-hand side, you can see the traditional underground map as modified by the new stations that were introduced. So that's quite a historic moment when that first appeared for us to have made a significant change to the Beck underground map. So TfL is a transport system, and London Underground is a subsystem of the wider TfL. An underground line, such as the Northern Line, is a subsystem of the wider London Underground, and an LU station is a subsystem of the Northern Line, as are the tracks and the signalling. So therefore, a project or program to extend or modify the system, such as the Northern Line extension, is a series of interrelated subsystems which are designed to relate to the existing system, i.e. the Northern Line. And so these are the fundamental building blocks that we started with in order to progress the works. Next slide, please, Dave. Whoop. So yeah, we're going to talk a little bit about safety and technical assurance now. Safety and technical assurance, as I said right at the beginning here, is one of the key things that we do. It is how we demonstrate to ourselves and to any interested outside party, and certainly to the stakeholders and our customers, that we have delivered what we promised we would deliver, and that those assets that we have delivered will be safe and fit in operational use. Next slide, please. So this is the V life cycle that we used on NLE. This will be familiar to many of you in terms of broad principle. It shows how we relate the input information for requirements into our works information. So we've got maintenance concept, we've got sponsor requirements, and we've got an operational concept. They feed into the works information, and then we move on to develop the design and show how the works are assured, and as the design and subsequently the construction progresses. And what we've done here also, because it's invariably the case that our contractors use the Royal Institute of British Architects design stages to develop their design. So we've related our V life cycle to the Royal Institute of British Architect design stages also, which helped to understand the relationship between the two. Next slide, please, Dave. So verification and validation. So first of all, we start out, as I said a few moments ago, with our requirements. We trace them back to the original documents where we establish our base requirements. And as the design is developed, we're constantly verifying that as the design is produced, that it is still going to deliver on those base requirements that we started out with. We then look, as we broaden out into verifying that the systems that are a product of the design are also delivering on those original requirements, and then ultimately our systems validation that the system that we have constructed is indeed delivering on those requirements. Next slide, please. So assurance and governance. So within TfL and more specifically within London Underground, we have certain things that we need to do in order to show that we are continuously assessing what we're doing and are in a good place to move on to the next stage. So at pre-planned key stages described in our migration plan, which we'll look at in a few moments, we had signaling review panels, or SRPs. On the Underground, we love an acronym, and the Northern Line extension was no exception to that. So these SRPs were convened to assess, with discipline specialists and independent persons, the maturity of the signaling system and its readiness to proceed to the next stage. Similarly, for the other disciplines, taking signaling status from the signaling review panel, we held system review groups. And they were convened at key stages, once again, seeking guidance from discipline specialists. And this was chaired by myself to assess overall program readiness to progress. And we'll look at that in a little bit more detail in a few moments. And in the final analysis, based upon an original change assurance plan, so right at the beginning, we produced a plan and said, these are the changes we're going to make. And this is the way that we will assure these changes. We put evidence from the SRPs and the SRGs, which in turn used evidence from something which we called IJBUs, which stands for Inspection and Test of Commissioning and Handover and Bringing into Use. And I'll talk a good deal more about that in a few moments, because that is key to the way we use systems to describe the makeup of the works and how all the elements work together and how the works were assured in their entirety. And this was taken to our Directors, Risk and Change Control team, DRACT, which is how London Underground demonstrates adherence with the requirements of the Office of Road and Rail. Okay, next slide. So, program and schedule and migration planning. Next slide, please. So, the program or the schedule for the program of works. The Northern Line works schedule included the design, construction, testing, commissioning, and handover, not just the physical works. Now, this may sound like just plain old common sense, but when you have a contractor producing, being your primary mover for producing a program or schedule of works, invariably the focus is on the physical works, and often the paperwork associated with it is not included. But we made a real effort here to make sure that the appropriate amounts of time were included for the production of all of the paperwork associated. This meant that we had the time in the program, and it allowed us to not to cram too much into the end state of the program, and it gave us the time to deliver what was required with confidence. We used systems engineering and integration principles to embed the necessary detail in the program. We started at an early stage with a sort of high-level strategic commissioning and handover plan, which I'll talk about in a little bit more detail. This embedded the time in the program, and as the works progressed and as we approached the end state, we were able to start populating those bodies of time with the detail of what it was that we were going to be delivering in terms of commissioning and handover. Next slide, please, Dave. So migration planning. We had an NLE migration matrix. Lists the design and build contractors and LU subsystem deliverables and their planned status for each migration phase in terms of entry criteria for the migration phase, activities taking place during the migration phase, and then the exit criteria, which will allow us to move to the next phase. And this, of course, informed the work schedule. You can see a little illustration of what we were doing there on the right-hand side of this slide. Next slide, please, Dave. So the matrix. So on a program of works the size of the Northern Line extension, both the construction and subsystems testing elements of the program were numerous. So there wasn't just one construction phase and just one subsystem testing phase. So there were many of them that we did before we could get to the point where we could have our engineers railway. We've got our systems engineering process and activities taking place throughout. We've got our phased systems integration, which includes for our HBOs, and then we've got evidence completion of the phase of the works. And we manage this through our system review groups and our signaling review panels to show that we had built what we intended to build, that our design, which was linked back to original requirements, is what in fact we delivered. And where, as is always the case with construction, we at times deviated from that, we had a process to demonstrate that those changes were managed and that they did relate back properly to compliance. We had our technical assurance and we had our safety assurance. So we went through construction, we had our reviews, we went through substance testings, we had our reviews. At a point in time, whilst we were under construction, the works were physically separated from the operational railway. There came a point in time where we had a physical link to the operational railway. We kept it isolated from a signalling perspective initially, and that was our engineers' railway. So we had a physical link, that is to say the railway was physically connected, but it was isolated from a signalling perspective. And we spent a good deal of time getting the systems within engineers' railway all functioning properly before ultimately we moved on to trial operations, where we had a series of scenarios which we knew could occur, and we tested the system pretty much to breaking point to make sure that what we built could accommodate those trial operation requirements. And then ultimately, when we were satisfied, I see some questions coming up, and I will address those questions. We'll go to the chat when I've finished the presentation, and we'll go to the chat and pick up those questions at that point, if that's agreeable to people. So at a point in time when we finished our trial operations, we then moved into revenue service. So at that point, we were satisfied. We'd demonstrated to those that we needed to, not least of which Dract, as I referred to earlier, that we had built what we intended to and that it was working as we anticipated it would. And therefore, at that point, we were able to deliver the works into revenue service. So through the applications of systems engineering approach, the migration matrix was created for the NLE as illustrated above. The matrix structure was captured in an Excel spreadsheet and used dynamically through the course of the project to plan for and control exit from one phase and entry into the following phase, providing the requisite evidence to the applicable SRG, that is to say Systems Review Group, or SRP, Signaling Review Panel, for approval. Next slide, please, Dave. So commissioning and handover. So a systems engineering approach provided the framework for commissioning and handover. And pursuant to this, at the very earliest stage, that is to say in 2015, and the works were delivered in 2020, so 5 years prior to being delivered, we put together a commissioning and handover plan, and it was agreed with the design and build contractor. And this in turn informed the work schedule. So this plan that we agreed was embedded in the work schedule and refined as the works progressed and as we approached the commissioning and handover stage of the works. Next slide, please, Dave. So a little bit more about inspection tests for commissioning and handover and bringing into use. So the Northern Line extension was a number of pieces of work. We broke the program of works into manageable chunks, to put it bluntly, and each one of those was an ICHBU. So a collection of data that included inspection and testing for commissioning and handover and bringing into use. It included everything from the original concept design and the requirements from which that concept came, through to the detailed design, full compliance, and all of the evidence that was produced during the execution of the works to demonstrate that we had built what we said we would build. We broke it into manageable packages because of the scale of the works. Obviously, there were, broadly speaking, 25 ICHBUs that were based upon something that was either geographical or systems based, and usually a combination of the two. Each package is considered as a system of interrelated elements that work together. The packages document fitness for use by collating assurance evidence of construction in line with design and commissioning that aligns with performance requirements. Each ICHBU is considered as a subsystem of the wider system that is the Northern Line extension. An overarching ICHBU, referencing the other package ICHBUs, documents that the NLE works as a whole and relates to the wider system that is the Northern Line. The scope matrix opposite was created to provide visibility of the design and build work package scopes with the disciplines involved, and to identify touching points with what we refer to as the LU16 projects or work packages. This approach supported an integrated and coherent assurance regime. So on the right-hand side of this slide, and I appreciate it's quite difficult to see, but on the left-hand side of the right-hand diagram, we've got the various ICHBUs, the packages that we broke the works up into, and on the right-hand side we have the LU16 and how they interfaced with those works. At the foot of the page, there are some ancillary ICHBUs that related to other works, but didn't directly relate to the relationship between the LU16 and the design and build works, and that's why they've been kept separate. But nonetheless, all of these works were assured, and sometimes with third parties like Thames Water, the local electricity board, etc. Next slide, please, Dave. So getting the message across. It was really important that we had a means of communicating what the grand plan was, as I referred to right at the beginning of this presentation. For me, if you want your team to be active participants, to buy into what it is you're trying to do, you've got to make it very clear what it is you're doing and how they can contribute. And so that's what we did. So each aspect of the migration plan, the commissioning and handover plan, and the program schedule was communicated on a regular basis to the whole delivery team, to the workforce. It was communicated to the whole delivery team, as we said here, clients, contractors and stakeholders, providing an explanation as to how each team member can contribute to the successful delivery, depending upon their role and the level that they operate at. Nobody could say that they didn't know, or at least hadn't been told how to do their bit. And it really worked. Nobody had what is sometimes referred to as plausible deniability. Everybody had been told what it was that they had to do to contribute to success. And therefore, for the most part, they did what they were asked to do because they were clear what was required of them. And this was regularly updated and was delivered consistently as a joint presentation by the client and the design and build contractor. Next slide, please, Dave. So, success. The key tenets for success in this case, as far as I am concerned, is good communication as the number one. Articulating a clear vision of the project and what was needed to achieve success, and communicating this to the whole project team, including stakeholders, so that they were motivated and understood the strategic view or delivery and had a vested interest in project success. And then joined up thinking, or to put it another way, systems engineering and integration. We use this as an approach to design, construction, and delivery in general. This ensured everything worked together and provided a framework for collation of assurance evidence to demonstrate readiness for delivery into service. Final slide, I think, please, Dave. Thank you for listening. And we will now take questions, which if somebody could go to the chat and articulate those questions initially, those that have raised questions during the presentation, we'll deal with those first, and then we can, I assume, I'm not as familiar with Zoom as I am with Microsoft Teams, but I imagine there's a facility to raise hands. So once we've dealt with the questions in the chat, if people could raise hands, that would be good.
Yes. Thank you very much, Dave and David. People can raise hands. There is a React thing, so which allows you to raise hands. So that's one way to do it. I can also go down the list, but let's see if anybody wants to raise their hand. I'll look in the list and see if there's any particular questions. Let's see. B2. Okay, sharing the link.
Looks like there's 4 questions so far, Mike, in the chat.
Should we deal with those first, and then we can see who else wants to raise hands? Somebody wants to read them out for me, and probably Dave will answer these. That was the agreed division of labor, but we'll see how we go.
Okay, let's see, Dale. The first one I see is from Nathan King.
That's it. Yep.
Okay. And he asks, may I ask how big the systems engineering and assurance team at NLE was? Roughly how many people were employed for the capability? Would you consider this enough or not enough?
Okay, I'm going to start that, and then I'll allow Dave to finish. So we had a team of engineers that were numbered between 35 and 40 at peak. Not all of them were system specialists, but they were all indoctrinated, as I said, into the approach that we were taking. So everybody made a contribution, but the actual systems engineering team was quite modest, and I will allow Dave to elaborate on that if he would, please.
Yeah, I would guess there's probably we'd say 4 or 5 people. This included requirements engineers, systems integration engineers, and in the early days, architect, system architect type people. So it's sort of fairly modest team, but I think what David was saying, that the sort of modus operandi was in ingrained in people. You know, we sort of preached the message, and it was taken on board. So,
And I think it's worth saying that we were demonstrably successful. So in terms of the question, was it enough? I think it was, because we had quality, not quantity. Let's put it that way.
yeah, I must say, on some other projects I've been involved in, there's been sort of some quite big and heavy systems engineering teams, and it's become an industry in itself, and in some ways counterproductive. So we didn't have that problem on this project.
No. I mean, everybody worked jolly hard. We certainly got our money's worth out of Dave and his team on Italy, that's for sure. But it was a modest team, but they delivered nonetheless. Yeah, we're very happy with the way things panned out.
All right. I have one from Bruce Elliott. To extend a railway, one needs to change some non-physical elements, like the timetable. Could you discuss how changes to the timetable, etc., were coordinated with the changes to and construction of new assets, please?
Wow. Do you know what? I'm going to let you try that one, Dave.
I think as we went through the various stages, and before we went into revenue service, we went into trial operation. And trial operations, which is allowing the operators to run the railway for themselves without passengers over a weekend, and they would use the timetables over that period. So in the background, London Underground are always working on new timetables and that sort of thing. There's a whole team that does that, and they would develop a new timetable to account for the additional trains and routes that came with the NLE. But we would try these out over a weekend without any passengers on board.
Okay.
Yeah. And that worked quite well. And of course, we were told what the aspiration was in terms of trains per hour, and our technical design of the permanent way sought to achieve that. But then, as Dave said, during trial operations, we refined and were able to demonstrate that we were able to achieve what the original aspiration. And
prior to doing the sort of physical demonstration, we also did performance modelling. So
indeed.
we would ensure that we were capable we could project that we would be able to meet the timetable aspirations.
Okay. Next, let's see, we have from Sanjeev Apricharla. He's asked, was a systems engineering master plan, ASEMP, prepared at any stage of the project?
Most definitely, yes.
Okay.
Yeah. I mean, we had a systems engineering management plan. We also had a systems integration plan. They were produced chiefly by our design and build contractor, but also we had our own overarching strategic documents that sort of corralled those documents and made sure that they were meeting our needs. Anything you want to add to that, Dave?
Yeah, I can say, whilst the contractor, they produced their own systems engineering management plan, they were contracted to do that. They were obliged to do that through the contract. But we produce an overarching systems integration management plan, and we updated that as the project progressed to reflect, the needs of the project.
Indeed.
Okay. Let me see, from Stephen Bull, he asked, can you give any specific examples of specific issues which were solved by the application of the systems engineering approach?
Well, I'm going to refer back to what I said about ITCBUs for a moment. I'm not going to go into too much detail because it's a bit of a hobby horse of mine, and I can get a bit boring about this. But for me, systems engineering was absolutely key to the commissioning and the handover of the project. We needed to be able to demonstrate that all of the various elements that are being constructed were working in harmony within their own immediate sphere, but also within the wider context of the Northern Line extension, and also the interface with the Northern Line. And so, you know, that systems engineering thinking was absolutely key to the successful commissioning and handover process, which we ultimately used to help us deliver.
Yeah, I think in terms of problems that were solved or issues resolved, the sort of the day-to-day issues were dealt with within sort of a systems engineering framework. But I think the whole point was that we tried to avoid issues. And that is the goal of systems engineering, isn't it? To avoid major issues, and I think we were successful in doing that.
All right.
Yeah.
Okay.
Yeah, we preempted a lot of issues by use of the interface control document register. It worked extremely well for us.
Okay. I noticed there were two hands raised, one by Simon and now by Srini. I was just going off the items on the chat. However, if you have something quick you'd like to ask, or I can do it when I finish the ones that were put in the chat. Srini, Simon?
Yeah, I can go if you want me to, Mike.
Okay.
Yep. Thank you for the wonderful presentation, David and Dave. Quick question. I mean, I have two parts to my question. One, you talked about the track framework for systems architecture and, you know, management of interfaces. I would love to hear more about that. And second, given the extent of this program, 240 interfaces seemed a little less to me. Is that because LU, London Underground, took care of the part 2, and that is why you think the interfaces were quite less? And maybe third part is, this side of the world, we tend to believe that, you know, we have 3 or 4 different contracts running, and that obviously increases the complexity of interface management. In your view, what do you think? Having more contracts, you know, is wiser, or having lesser is wiser? How do you see that?
I'll let you go first, Dave.
To take the second question, I think the number of interfaces. I think we were not dealing with sort of internal interfaces. These are all interfaces between sort of external entities, if you like, or between systems and subsystems. So, I mean, you know, you're quite right. There are, in a complex system like this, numerous interfaces, but the ones that needed to be managed were the 240 that we recorded on the interface register. To go back to your question about the track, I mean, this is not particularly my sort of area, but we had a systems architect, and he used a tool called Track, which is used for designing systems architecture. It produces all the drawings, all that sort of thing, and then out of that, it produces what David referred to as the objects and interfaces register. So this is so you start off by doing the architectural drawing, systems architecture, and then it produces the interface register and has identified all the objects. And that was what we passed on to our design and build contract.
Okay.
The final question, what was that? There were 3 questions.
Yeah, 3 parts. I think the third part was to do with something to do with multiple contracts, something like that.
Yeah.
Srini, could you repeat it? Would you mind?
Yeah, in your mind, having lesser contracts is better to manage a program of this complexity, or dispersing that into multiple contracts and managing that is wiser? I just wanted to hear from you, from your perspective, you know.
Well, I'm going to start on that one, Dave, and by all means,
Yeah.
chip in if you'd like to. for me, the fact that we had a single design and build contractor who was responsible for most things, and also then responsible for the integration of the works of others, was key to this. Well, one of the key things that gave us the success that we had, because we worked very hard with that design and build contractor to educate them and make sure that they understood and delivered on their obligations. And so we were able to use them to do, frankly, the donkey work. And quite right too. That's what we were paying them for, amongst other things. The other 16 separate contracts, it is in the nature of the way that TfL, and more particularly London Underground, is set up, that we have pre-existing contracts with various elements within the business. And the simplest way to deliver those was to maintain those contracts and relationships, and simply ask the single design and build contractor to assure the interfaces between that work and their own. And so that worked quite well for us. So for me, keeping the number of key accountable persons or bodies to a minimum can only be helpful. The more you have, the more complicated it becomes. That's my personal opinion.
Thank you, David.
I would
Appreciate
agree
it.
with that.
All right. There are a couple left on the chat. So Dale had a question on, from your lessons learned discussion at the conclusion of the program, did you generate any contract-specific lessons that could be preventative for future large contracts?
Wow. Sorry, could you repeat that for me?
Yes. From your lessons learned discussion at the conclusion of the program, did you generate any contract-specific lessons or lessons learned that could be preventative for future large contracts? That was
yes, we did. We many, but and the list is almost too long to try and roll out here. But what I would say is that, in general terms, that the NEC form of contract is based upon something called a works information, which is something. It's a document which describes what needs to be delivered, amongst other things. And in many instances, how things need to be delivered as well. And what we discovered, and what we are constantly discovering, is that that is not sufficiently specific in many instances. So it's a live, our works information that we use is a live document. It is constantly being enhanced and improved. And I have no doubt that the lessons that we learned from the Northern Ireland extension are now embedded in works information clauses, which are now used across the business. In terms of specifics, well, the one area where we had great difficulty was actually where our own works information was pretty strong in this case. Well, and it was to do with systems integration and that the responsibilities that were held by the contractor, although the contractor hadn't properly understood them, we were reasonably strong on that, and were able to use that to get the contractor to deliver on what they had signed up to do. But yeah, there were a number of things where I know that the works information has been bolstered and enhanced as a consequence. But I'm struggling to think of any that I can list out right now, to be perfectly honest.
Yeah, the one that I was interested in was the lesson learned about that the contractor after the fact stated or made clear that they couldn't really handle systems integration.
Well, what happened there was, and I'm sure this is familiar to many of you, is when they won the work, they did so fielding their A team. when they went to work, they fielded their B team or even their C team, perhaps.
Classic.
Yeah, exactly. And so this was the problem that we were faced with. The people that won the work understood the obligation. The people that were actually given the reins to actually then deliver the work were less well equipped, and we had to educate them. But we were able to do so.
If I could add something there, David. I think when they bid for the work, they described what they were going to do in terms of systems integration in glowing terms, and it was sort of a wonderful exam answer, you know.
Yeah.
I think where, from me, a lesson learned, we didn't sort of embed that into our works information. You know, if we'd have put in what they said and turned that around on them, we would have had the specifics that we needed, but we ended up having to argue the point.
That's a very good point. Very well made, Dave. Yeah.
Yeah, fantastic. Thank you. Just for everybody on the call, we're going to let the Q&A continue. For those of you that are able to stay, our very fine presenters have generously offered to hang around and try to answer all the questions and keep the discussion going. For those of you that have to go, thank you for attending, and we'll carry on now. Thank you.
Okay. I just have a few more. Let's see, from Fumi Natuli, he asks, with the project running at a point when COVID and its respective restrictions hit, were there no CEs, given that the project was delivered on time and within cost budget, or was there sufficient buffer to account for the CEs? Fumi, CEs?
Compensation events.
Okay.
This person is obviously familiar with the NEC form of contract, and so yes, there were compensation events raised, but we were able to accommodate them within the original time frame. And it's interesting to note that in many instances, strange though this may sound, COVID in some ways helped us in terms of being able to get people to meetings to make decisions, because we were now actually able to get people to virtual meetings, and people didn't have to travel great distances and what have you. It actually helped us, and we were, people couldn't say, "Oh, well, I can't make that meeting," because they could, and so it had a beneficial effect in us able to get decision makers to meetings and move things along. In terms of the physical works, it certainly presented some serious challenges. But to be fair, our contractor stepped up. In some ways, I probably could be accused of being a little disparaging about our contractor. But you know what? They did a fabulous job. We couldn't have delivered the works without them, self-evidently. When their backs were against the wall, they stepped up and they got it done. And they did so in very difficult conditions. Fortunately, the bulk of the physical works were complete at that time in terms of the infrastructure. Lots of the systems works could be done remotely. And because of the scale of the works, people were able to maintain a level of separation from each other, which allowed the works to progress, perhaps when on a smaller site that may not have been possible.
Okay. Steve Dennehy asks, what was your requirements hierarchy? How many levels? How many requirements on each level? You mentioned stages of verification and validation. Did you verify against requirements at each hierarchical level?
I would have to say yes. I mean, we have had a full-time requirements engineer working on this, and we normally do sort of systems requirements level SRS, and then we go to TRS, and then it goes into the sort of the works information, the contractual information. So I don't know if that answers the question.
Follow the process. Yes.
Yeah. Yeah, certainly in terms of requirements, we constantly referenced back to the original requirements to make sure that we were delivering what was asked for and what the customer expected. And we spent a lot of time working with the customer and keeping them on side, as it were, so that they knew what they were going to be getting. But yes, a lot of effort was spent making sure that we constantly referred back to the original requirements and that we weren't deviating from the original intent.
Got it. Yes, nothing lost in translation. Got it.
Yeah.
Matt Gibson asks, very often the challenge to making systems engineering effort effective is how the project's leadership chooses to utilize it to inform the overall project's decision making. Do you have any reflections on how you brought the wider project leadership on this journey, encouraging them away from the temptations of shouting louder about delivery and focusing on project outcomes and system states?
Yes, I was fortunate. I think we were fortunate, but I think I was particularly fortunate in that my opposite number within the main contracting organization was somebody that was known to me, and we had a pre-existing working relationship. It allowed us, therefore, to develop a good working relationship on the project and to develop a strategy that we both agreed and believed in. It was then a lot easier because rather than me trying to convince the contractor or the contractor trying to convince myself and my project director, we were speaking to a large extent with one voice. They obviously had commercial considerations. They had obligations they needed to meet in terms of profit margins. But at the end of the day, that is to say, my opposite number and I understood that in order for them to deliver, they needed to provide us with certain things. And we were clear on what those things were, what that assurance looked like. And we then made a joint communication, which came from the top down. And it was done almost to the extent that people started getting sick of hearing us, but there was never any opportunity for somebody to say they didn't know. And the senior people, both within the contracting organization and within London Underground, all bought into the same message. And that was key to getting the message across and maintaining the message and delivering.
All right. Thank you very much. That was from Matt Gibson, by the way. Proves our head of our rig committee. Bruce Elliott says, thank you very much. Srini says, could the slides be shared with the team?
Certainly. Yeah.
Okay. And then we have Steve Dennehy making a comment. My experience of design contractors is that they tend to structure their work around design packages rather than around a hierarchy of components, assemblies, subsystems, each subject to verification and integration. What enabled you to be successful in getting a focus on integration from early on?
So I would say the fact that if you recall, I said when I joined the project in 2015, one of the first things I did was agree an asset commissioning and a handover management plan with the contractor. So this set the framework for what needed to be delivered and how it needed to be delivered, what the assurance would look like, and therefore also dictated to a large extent the design and how the design was developed. And so with that backdrop of this commissioning and handover management plan, the design that subsequently followed recognized that, or was obliged to recognize that, and therefore the design aligned with the commissioning and handover delivery process because it was obliged to, because that existed before all of the designs were fully developed.
Yeah, I think that's observation is quite appropriate because we handed over to the contractor the sort of the contractual works information, and we expected them to actually do what you said and to flow down into requirements equivalent to what we do in systems, and they didn't do that.
No.
And instead they took the works information and they broke it down into work packages. So they had 25 work packages, but through monitoring what they were sort of putting in these work packages, and for us, we could then sort of for ourselves relate it back to whether they were delivering to our requirements. But as you say, design and build contractors, that's what they do. They create work.
Yeah. The classic divide between project management and systems engineering, and trying to get those two worlds together.
Yeah.
Very good. Okay, the rest was about the discussion on track, which is I thought that was good. You brought that out. That's the architectural framework you used, which seems like it had a lot of benefits in clarifying things and in developing your interface definitions. And everybody else basically says thank you for the presentation. So well done. And everybody, if you want to give a clap on the React, please do. And then we can finish up the webinar. Thank you, Dave and David, for your time. And this will be recorded, and it'll be linked on the Dale will capture the recording, and then it'll go on to the TWG YouTube website. So along with all our other webinars, so people will be able to watch you years from now and enjoy your great presentation. And thank you very much.
Yeah, thank you, gentlemen. And I'm going to stop the recording.
Okay.